So we're looking at this paper 6, and we've been told that it's all about nearest neighbours, nearest points to the origin, 0, 0. And the nearest neighbours to that have been highlighted in little circles there, and it's asking us to find the second nearest neighbours. So I'm going to highlight these by writing number 2, because we might want to do more than that later on. I know we will. So those are the second nearest neighbours, second closest points, and they're all equidistant from 0, 0, the origin. So we've got to write down the coordinates. So just list them out. So it'd be -1 and 1, -1 and -1, 1 and -1, and of course 1, 1. So those would be the 4 points. Second question, the distance from 0, 0 to its first nearest neighbour is 1. For example there, that is 1 unit. Show the distance from 0, 0 to 1, 1 is √2. So 0, 0 to 1, 1 would be from here to there. So it's a little baby right angle triangle. So here it is. There's the right angle. We know that distance is 1, that distance is 1. So you're finding this distance here. So we're using Pythagoras. So remember with paper 6, that you really should show as much working out as possible to try and pick up those communication marks. So there we go. I've done that beautifully, I think. So I've used Pythagoras and I've shown that distance is √2. I realise I haven't shown it for you though. So there's the big reveal. So I drew a beautiful little diagram, and then I wrote out Pythagoras' theorem and solved to find the distance. Right, the next one is this. So we've got a table here showing the nearest neighbour, first nearest neighbour, second nearest neighbour, third nearest neighbour, the distance from the origin to the nearest neighbour squared, and then the actual distance, so the square root of the other one. That means this is going to be easy to fill in. To get from d squared to d, we just need to square root it. The square root of 4 is 2. The square root of 5 is √5. Then number of nearest neighbours. So for 2, well, we've already done that because I cleverly wrote down 2, 2, 2, 2. So there are 4. And then for 3, so the next nearest neighbour, that would be here, 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 and there. So they're the third nearest neighbour. So there are 4 of those as well. And now we've got to get the fourth nearest neighbour. So the fourth nearest neighbour, well, it wouldn't be this one here. That's a little bit further away. These ones are a bit closer. So that would be the fourth nearest neighbour. And that's going to be the same distance. So that's also going to be the fourth nearest neighbour, as is that, 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 as is that. So there are 8 fourth nearest neighbours. So that's that done. Is d squared proportional to n? So is d squared fishy n? This is one way to do it. Remember, you can set up the equation. So if it's proportional, it'd have a constant, k. And if they are proportional, that constant would stay the same in the formula the whole time. The same as it does, for example, with, a equals pi r squared. The constant remains the same. It's always pi, so it wouldn't change if they're directly proportional to each other. So what we need to do is work out what the constant is. So you substitute in your values of, it'd be d squared and n in this case. So we could sub in n equals 1, and when n equals 1, d squared equals 1 as well. So those values are just taken from there. 1 is going to be equal to k, looking at that equation, times 1. So rearrange it, and the constant of proportionality is 1. Now, let's pick another pair. So let's do 3 and 4. Now, if it is proportional, we'll get the same constant. So let's check that. So n equals 3, d squared equals 4. And substitute into here. So d squared is 4 equals k times n, where n is 3. And what we'll see is that the constant is different. So as the constant is different, then it's not a proportional relationship. They're not directly proportional. The constant would have to be the same. So that's one way of showing that they are not proportional to each other. Right, the next question is quite tricky. The 12 nearest neighbours to 0, 0 are a distance h, where h squared equals 20. You've got to find the coordinates of the nearest neighbours. Now remember, it represents a distance. So if I take the square root of that, or h squared is the square of the distance, where h is the distance. So we've got to recall where the root 20 comes from. Well, we're finding the distance between these 2 points. So using Pythagoras' theorem. So that distance would be root 20. And say we're looking at these 2 lengths here. We know that a squared plus b squared is equal to root 20 squared, which is 20. So you've got basically 2 square numbers must add up to 20. So we've got to look for square numbers. So something squared plus something squared. But there aren't that many squared numbers which are going to add up to 20. In fact, there are only 2. So we've already found our answer. They have to be 4 and 16. Those are the 2 square numbers which are going to add up to 20. Because think about the square. You've got not many. You've got 1, 4, you have 9 and 16 before you get to 20. So the only combination of those square numbers which is going to give you 20, which is going to work, is 4 and 16. So if a squared is 4 and b squared is 16, we then know that a is 2 and b is 4. So we found the 2 lengths. They have to be, for this to be true, they have to be 2 and 4. So you've got to think of all the different combinations of this. There are loads. So 2 and 4, I'll try and maybe use a different color here. So you've got lots and lots of them. So it could be here, for example. So you could have 4 and 2, but it could also be here as well. And then you've got all the negative combinations. So you've got -2 and 4, 2 and -4. So you're going to go all the way around here. There are going to be 8 different ways, and all of these will give the same length. Look at it. Doesn't matter. Every combination of a length of 2 and 4 will give you the same length. So if we have to list all of those out, it's going to be as follows then. So you're going to have 2, 4 is one combination. You got 4 and 2. You got -2 and -4. You got -4 and -2. You got -2 and 4. 2 and -4. -4 and 2. And 4 and -2. All of those would work. All of those would give you the coordinates of a distance of root 20. And we got that all from Pythagoras. Right, let's move on. Funny one, but we'll do it anyway. So number 4. So they've listed some more nearest neighbours. All you got to do here really is find the 4th nearest neighbour. So the first 3 have been done for us, and you've got to find d squared, and you've also got to find the number of nearest neighbours. Well, the next nearest neighbour is going to be here, if we follow the kind of pattern that they've been showing there. So if that's the next nearest neighbour, we've got to find the distance squared. Well, fair enough, it's Pythagoras again. So if I know that is 2, then I know square root of 2 squared plus 2 squared is the square root of 8. So the distance is the square root of 8. So d is root 8, which means d squared then, square both sides, d squared is going to be 8. So that's that part done. Number of nearest neighbours, well, there should be 4. So there's going to be another one here and another one there. So it'll be 8 and 4. Right, next one then. So this is a grid made up of equilateral triangles, and the circle showed the first and second neighbours to 0, 0. So we're going from 0, 0 again, but the grid is a diagonal grid, so it's and it's made up of equilateral triangles, which is going to be important. So complete this table to show when a point is an integer whole number distance from 0, 0. So we've got to look at these points. Look at this one first, -1, 1, and see, let's just investigate them. So -1 is the x-axis. So we go across, and then you go up to 1. So B here. So -1 for x, up to 1. Is that a whole number distance from 0, 0? Yes, it is. Because it's an equilateral triangle. So every one of those lines there is going to be a whole number. So that's a tick. Yes, it is. Right, let's look at minus 1, 2 then. So minus 1 is the x-axis, and then we're going up to 2. And if we look at this distance, that's not along the same lines, is it? It's not one of those. So that's not going to be a whole number. It's not going along the lines of the equilateral triangle. So that's a no. So you tick the no part. 2 minus 2. So you're going across 2, and then we're going down to minus 2. So you're here. So this is going to be a whole number, because look at this. You're going along the sides of the equilateral triangles, and each one of them is worth 1 unit. So that's 2 units. So yes, the distance is going to be a whole number. Let's try 2, 2 then. So you go across 2 and up 2. So we're here. And this time that's going to be a no then. Because look, that is not going through your lovely whole unit equilateral triangle lengths. So that is not going to be an integer distance. Right, okay, let's look at 0 minus 3. So 0, then down to minus 3. And that hopefully clearly is going to be a whole number distance. Look, because all parts of that journey are going along the sides of the 1 unit equilateral triangle. So that would be a whole number distance. Right, the point A4 is the next one, is an integer distance from 0, 0, write down 2 possible values for A. Well, the first one should be really easy to spot. So the second value is 4. So the Y value is 4. So if we go back to here, that is clearly a valid option. So 0 for x and y for, look, it's definitely give you a whole number one. It goes all along the lines of the equilateral triangle. And each one of those units is 1, so it'll be 4 units. So very much an integer distance. So the first one then is going to be 0, 4. So the value of a then is 0. And then finding another one where it does that, you're going to have to move along. So I think to here. So if we move along to there, can we see that this also means we travel all along the sides of the equilateral triangles to get to 0, 0. For example, we picked another place like there. It doesn't travel along the lengths of the equilateral triangle. So it's not going to give us, a whole integer distance. But here we travel 1 unit, 2 units, 3 units, 4 whole units. So it's a whole number, an integer distance. So that will be our next one then, that works. So that is, it's exciting, is minus 4 and 4. So the second one is minus 4 then. Why is that minus 4? Have a look. Remember, these are diagonals. So it's going down diagonally here for the y-axis. So that would be minus 4 for the y part. So it moves on to something a little bit different here. Well, say a little bit different. It's quite similar. So we've got another grid, more distances from the origin, and we've got to explain why the largest angle in this triangle is 120 degrees. Well, that's the largest angle. The reasoning is found in the description. So this grid, again, is made from equilateral triangles. So in other words, this here is an equilateral triangle. And as we should know, the angles of an equilateral triangle are 60 degrees. So if that angle is 60 degrees, then this angle here must be 120 degrees. So it's as simple as that. So you need to explain that in words. Right, calculate the distance of 1, 2 from 0, 0. So this is going to be cosine rule. So 1, 2 is 1 across and then 2 up. So it's here. So it's the distance d then. So from 0, 0 to 1, 2. So cosine rule. So it's going to be the distance we're trying to find, d squared, is equal to the other two sides that we've got. So they were given to us as 1 and 2, I believe. So this is 1 and that is 2. So they're either side of the trapped angle. So it's going to be 1 squared plus 2 squared minus 2 times the other two sides. So 1 times 2 times by cos of 120. And you hopefully can get used to doing, you obviously got the formula, so you can use the formula, but you should be able to do this quite quickly. Remember that the angle here, 120, is linked to its opposite side. And then you can fill in the 1, 2, the 1, 2 from the two missing sides very easily in between. That's how I remember it and do it. So you've always got the angle and you've got the opposite side to it, which is D. And then you can fill in the middle bits with the other two sides. If we evaluate that then, and I'll try to do it fairly fully, even though I've run out of space here, because the more working out we show, the better. So if I multiplied that out, I get that. Then cos 120 is minus a half. So that would mean d squared is 7. And then d is the square root of 7, which would be 2.65 to 3 significant figures. Right, part C, show that its distance d from 0, 0 is given by that formula. Well, this is going to be the same thing. Again, it's going to be an angle of 120 degrees every single time. Hopefully, you can show why in a minute. So if we are moving along here like this pattern is repeated every single time. So if I've got coordinates, say, let's see, 2, I've drawn here, 2, 2, and the distance is going to be from this point to the origin, as always, then the angle here is going to be made up of an equilateral triangle on the other side. So it's always going to be 120 degrees, the angle. Look, if I move it across to here, same thing. So exactly the same. So if I move it to, that is 3, 2, same thing. Again, I've got a 120 degree angle. So it doesn't matter where we are, that angle stays the same. So we need to utilize that. And we can do. So again, I'm going to write out the formula in very quick style. So it's going to be the distance again. So d squared equals the sides, which are going to be the coordinates, which are going to be A is always going to be, say, this distance for the last one. And then B is that slanted Y difference there. So they change as they go along. They vary. But the X part was A. The Y part was B. So they are the other two lengths then. So it's going to be A squared plus B squared minus 2 times the lengths. So 2 times A times B. And remember, it's always cos 120. And then we just need to rearrange that. And we're going to get the formula they've got there. So let's do that then, I guess. So D squared is A squared plus B squared. Recall that cos 120 is minus a half. You can put it in your calculator, don't believe me. Minus a half times minus 2 is going to just give us plus 1. So it's going to be plus AB. And then take the square root of that, and we're done. So we proved it. And it'll be positive because we're looking at a length. So we have proved it. Use your formula in part C to calculate the distance of the 6th nearest neighbour. I'm going to astound you now, so I'm going to use a pair of compasses. So I think it's quite hard to see where the next nearest neighbour is. So I think it's easier if we use a pair of compasses and try to find it that way, because otherwise you could get the wrong one. Right, so I do believe that is it, but we can do a check now. You can't. Oh, my hand's in the way. I'm so sorry. I'm pretty satisfied with this, though. Yeah, So I've clearly found, beautifully, frankly, the next nearest neighbor there. So we can see they go around in the next circle. So on that circumference, I've got 1, 2, 3, 4, 5, 6. So I've got 6 nearest neighbors going around that circle. So I've just got to find the distance of it. So I can just pick any, well, actually, I'll say won't pick any ones because we're using that formula. So I'm going to set up the triangle the same way that is set up using the formula, which is using that angle of 120 degrees. So there we go. So that's the triangle that we would find. And let's look at the coordinates. So we can substitute in the values of A and B. Well, it looks like it's 2, 2. It is. So the coordinates at that point, 2 across and 2 up. So it's 2, 2. So using this formula, A is 2 and B is 2 as well. So let's sub in then. So I'm going to keep the formula there so we can just about see it. So D is equal to square root of 2 squared plus B is also 2. So that plus 2 squared plus 2 times 2. And if we calculate that out, we've got square root of 12, which we can then simplify if we want to. You could leave it as square root of 12, to be honest, but let's practice our surds. So 12 is 4 times 3. You can then take root 4 outside the brackets, and root 4 becomes 2. So if we simplify it, it's 2 root 3. Right. Oh, yeah, this is a tricky one. Right, okay, and I think there are a few ways you could do this. This is the most logical one for me. So this was a really tricky question. Use the formula that we've just derived to show that it is not possible for a nearest neighbor to be a distance of root 14 from 0, 0 on the triangular grid. So we can set it up like this. Start should be fairly obvious. So there we go. It is, the distance is root 14. I've just substituted it into the formula. Well, I can square both sides. So if I square both sides, I've got this. I'm then going to treat it as a quadratic. So in order to solve, and I'm going to solve it. So I'm going to solve it to make A the subject. So I'm going to rearrange it to, oh good Lord, what was that? To solve a quadratic, I have to make it equal to 0. And then I'm going to treat, normally we'd be used to it being x squared or whatever. But I'm going to make, A is going to be my x. So I'm going to solve to find x. So and that means if I do that, I'm just going to rearrange this slightly. So A squared is like my x squared. So I've got A squared plus, I'm going to rewrite it as BA, and then plus the rest of it is the constant. So it's kind of in this form. Normally it'd be, x squared plus bx plus b squared minus 14 equals 0. So in the form, we're used to ax, something x squared plus something x plus something with no x's equals 0. So it's written in that form. But I'm doing it, I'm going to keep it, I hope you can cope with this, all in terms of a, not x, because I'm going to make a the subject. So I'm going to use the quadratic formula here. So a equals, where it'd be minus b. Luckily, to make it easier, b is actually b in this case. So the coefficient of a, or which normally the coefficient of x, is b. So it's minus b plus or minus the square root of, well, it's b squared. That's kind of lucky. Minus 4 times, or what's the coefficient of a squared, or x squared as it normally be? Well, it's 1. There's 1a squared. And then times by c, which is the tricky part. C is all of this. It's the bit without an x, or the bit without an a. So it's b squared, so large I can't even put it in there. So b squared minus 14. And all over 2 times the coefficient of a squared in this case, or it'd be x squared. Well, it's 1a squared. So it's 2 times 1, which is 2. What we're going to focus on, we're going to focus on this part here. And this is actually genuinely going to help us. Right. I am going to simplify that. So I expand the brackets here. So I've got b squared minus 4 times 1 times b squared. So that's minus 4b squared. And then minus 4 times 1, which is minus 4, times minus 14, which is plus 56. Minus 4 times minus 14 is plus 56. All over 2. And then this simplifies further to this, because b squared minus 4b squared is 3b squared. Minus 3b squared, I'm sorry. So we got that. Why is this useful, you're thinking? Well, it is actually, because I am going to analyze this, what's in this square root, and it genuinely is going to help us. So I've got 56 minus 3b squared, or the square root of that. What I can look at then is, I'm going to do trial and error here. So I'm going to show you that when I substitute in values of b, they can't be whole numbers. So let's try b equals 0 first, just substituting into the square rooty bit. So it'd be 56 minus 0 squared times 3, which is 0. So it would equal 56. Can you take the square root of 56 and get a whole number? No. So it can't be b equals 0, because this has got to give us a whole number answer for a. So if this square rooty bit doesn't give us a whole number, a cannot be a whole number. So let's try b equals 1 then. Is that going to give us a whole number, which is what we want? Let's try. So b equals 1, I substitute in, so it'd be 56 minus 3 times 1 squared. 3 times 1 squared is 3. So it's 56 minus 3, which is 53. Can you take the square root of 53 and get a whole number answer? No. Let's try b equals 2 then. So b equals 2 is going to be 56 minus b squared is 4. 4 times 3 is 12. So it's going to give us 44. Can you take the square root of? No, you know the answer already. You can't. You can't take this. You don't get a whole number from square rooting 44. Right, b equals 3 then. We're nearly there. We're not doing this forever, by the way. So 56 minus b squared would be 3 squared. So 9. 9 times 3 is 27. So in this case, we're now looking at 56 minus 27, which is 29. Square root of 29, no thank you. B equals 4, substitute in again. So 56, b squared is 4 squared is 16, times by 3 is 48, which is 8. Square root of 8, no, that is not a whole number. And after this point, we can disregard it, because what happens is we get a negative number. So 56 minus 75, which is going to give us negative 19. And from that point onward, it should be obvious that all your solutions are going to be negative, and you can't get a real solution if you take the square root of a number. So b equals 6 is going to be the same, b equals 7, and that is it. That is your proof. So then you'd need to write out and explain that. So you have no whole number solutions to a distance of root 14, because you've tested them for b equals 0, 1, 2, 3, 4, and 5. And from that point onwards, you would get a negative number for a square root, and therefore you cannot have a whole number answer, because a could not be a whole number.